Imagine a building so tall that it scrapes the sky, a structure weighing hundreds of thousands of tons, yet standing firm against winds, earthquakes, and the relentless force of gravity. What if I told you that behind every modern skyscraper lies a hidden symphony of design, engineering, and human determination? Today, we're stepping inside the process to uncover how a modern skyscraper is really built. Skyscrapers are more than just tall buildings. They are symbols of ambition, technological progress, and human ingenuity. From the steel skeletons of early 20th century New York to the glass towers piercing today's city skylines, these structures embody the ultimate challenge. How high can we go? In this episode of The Process Inside, we'll break down each phase of skyscraper construction, from the ground beneath our feet to the final glass panel that glitters in the sun. Stay until the end, because the final step will surprise you. It's something most people never realize happens before the first tenant moves in. The foundation, building below before above. Every skyscraper begins not with steel, but with soil. Before a single beam rises, engineers must understand the ground. Deep drilling and soil analysis determine how much weight the earth can bear. Then comes excavation. Massive machines dig down dozens of meters, sometimes until they hit solid bedrock. That's when the real anchor of the building is born. The foundation. Concrete piles or caissons are drilled into the earth, reinforced with steel and filled with concrete. This underground structure becomes the invisible strength of the skyscraper. Without it, the tower would topple under its own weight. The skeleton of steel. With the foundation secure, the vertical race begins. The skyscraper's skeleton is made of structural steel, beams and columns assembled piece by piece like a giant 3D puzzle. Tower cranes rise alongside the building, lifting steel beams hundreds of feet in the air. Workers known as iron workers bolt them together in midair, sometimes balancing on beams as narrow as 12 inches across. To maintain stability, engineers create a rigid steel core in the center, housing elevators and stairwells, while the outer skeleton supports floors and windows. Slowly, floor by floor, the building reaches upward, transforming the skyline. Floors, systems, and services. A skyscraper isn't just an empty shell, it's a vertical city. Each floor must be poured with reinforced concrete slabs strong enough to support people, furniture, and equipment. Then comes the hidden systems: electricity, plumbing, fire safety, and, crucial in tall towers, the HVAC system. These must all be carefully designed to function vertically. Imagine water pressure needing to reach the 60th floor, or air conditioning balancing different levels of the building at once. Without these hidden arteries, a skyscraper would be unlivable. The curtain wall. Wrapping the giant, one of the most iconic parts of any modern skyscraper is its skin, the curtain wall. This is the shimmering glass and metal exterior that reflects the sky. Despite its beauty, the curtain wall is more than decoration. It must resist wind loads, insulate against heat and cold, and allow in natural light without overheating the building. Panels are prefabricated off-site, then hoisted into place, sometimes weighing several tons each. Workers install them one by one, slowly transforming a bare steel skeleton into a futuristic landmark. The vertical highway. Elevators. What good is a skyscraper if you can't reach the top? The invention of the safe elevator is what made skyscrapers possible. Modern towers install high-speed elevator systems that travel at over 20 miles per hour. Some even use double-deck cars, smart destination systems, and magnetic propulsion instead of cables. Installing elevators is one of the most complex phases because the elevator core defines the entire flow of the building. Wind, earthquakes, and invisible forces. The taller a building grows, the more it becomes a sail in the wind. Skyscrapers must sway, sometimes up to a meter at the top, but never collapse. Engineers use tuned mass dampers, giant weights hidden near the top floors, to counteract motion. In earthquake zones, flexible joints and shock absorbers allow the tower to bend without breaking. These hidden guardians ensure that even in nature's worst storms, the skyscraper stands tall. Interior finish and hidden secrets. Now the tower looks complete from the outside, but inside, an army of workers is still busy. Drywall, flooring, ceilings, lighting, and technology systems turn raw floors into usable offices, apartments, or hotels. The finishing process can take as long as the structural work itself. And here's the secret. Before the public ever steps inside, the building undergoes rigorous testing, fire drills, safety inspections, and commissioning, where every system is tested under real-world conditions. Only then is the skyscraper declared ready to open. A new landmark in the sky. From the invisible foundation buried deep underground to the shimmering glass facade glinting in the sun, a skyscraper is a masterpiece of modern civilization. Each one represents thousands of workers, years of effort, and the relentless human drive to rise higher. The next time you stand at the base of a tower and crane your neck to see its top, remember the hidden process inside. Because building a skyscraper is not just about concrete and steel, it's about vision, perseverance, and the belief that we can always reach further into the sky. This was the process inside. If you enjoyed this journey into skyscraper construction, make sure to like, subscribe, and tell me in the comments which process should we uncover next.